Hello, this is Cliff Collins. This is my video number 38 on our software development and computer technologies. So today I'd like to talk about our computer technology, and I want to look at a better approach, kind of consolidate the things I've said in the last 37 videos. So first I want to start with a vocabulary of what we'll be talking about. I came up with the term of record of human understanding. Give words out that make us understand. So when I say apple, elephant, tree, those words mean nothing to the computer. They are our reality words in our language. So we have the record of human understanding, RU, and then the record of computer understanding, those things that those values that the computer has that would help in our understanding. What line number something was changed, who changed it, when it was changed, process. And then we have the record of my understanding, things that I understand personally. So when I say move, those are my things that I stuck in there that are specific to me. I like the color blue. And then we have a record of device understanding. So all of our associated devices on our computer, certain things that it knows. It knows a number of sectors and other tracks and frequencies and voltages and all of these things that certain devices, and then they have protocols. So USB, each of those have a different protocol and so on and so on. And they have languages. So how do we talk to the mouse? How do we talk to the screen? All of that understanding is device specific. So we have our CPU one. I'll go into a simple example of our CPU device. And these are some of suggested changes just for that. We'd like a simpler instruction set and naming conventions. You know, we started out with the 8080 with all the device registers and sub-register device names. That really doesn't apply anymore. We need to get to more consistent. You know, if it's register 1, let's just say it's register 1. And our instruction set should be simpler, a lot less cryptic. Right now it's so cryptic and inconsistent. And we'd like to go to variable length numbers. We have fixed length numbers right now, 8, 16, 32, 64, 128 kind of thing. And I'd like to go, so I'd like my numbers to be both fixed. That's what we're using now, but we could also go to variable length or a larger, some specified fixed length, 3 bits. I want 3 bits or 8.5 bits or whatever it is. And then I'd also like to go to a 12-bit byte. This 8-bit byte is just not large enough for any significant logic, plus it's only in hex. If I went to 12-bit, I could represent that number in decimal, octal, and hex. And I'd like to have on our CPU, this CPU actions, I'd like data type specific action. So if I'd like to know that I'm adding 2 numbers. And I'd like to see a robust assembler language. Right now it's still hardware instructions in our very, very cryptic language, when in actuality it's just very simple operations. We should make a simple assembler and very powerful that applies to all of our extensions. And I'd like a date value separated from a time value and have the actions for both. Record of device understanding. The CPU instruction set, we should be able to ask what that is. What exactly, so I want to get to hardware independence here. So I should be able to ask the CPU, what is your instruction set, and tell me exactly the number of bits and the structure of it, and then look up tables and everything else, so that we can actually automate this independent of the hardware. So one example would be A equals CPU to RDU, a record of device understanding data types. Or we could say our CPU, my understanding install date is equal to date. So I could set my understanding about this particular CPU. My understanding is, yes, I installed it today. And so the next change I'd like to see is in our characters. So I'd like our characters to be a basic technology. Basic means that it's built in to the compiler. It should be transportable so that I create a document, create a new character or want that character set in there to make sure that it should be customizable so everybody can create their own specific characters if they need to. Should be definable, means that yes, I put this character in there, I need to give you all the understanding that I have or the system has about. And every character should be stylized in any form. So this, like I said, this is a basic technology. It should be stylized. We need to take case out of our characters because that's a style. Basically, if we put it in, then we have case-sensitive text, which we can't search, so we have to convert everything to lowercase to search it. And so we have a lot of extra processing that we don't need to be doing, and we could speed things up by about 1,000 times simply by moving simply case out. Then we could add color and bold and underline and all the other styles, spacing and whatever, and then we could even search on those. So anything blue is mine, anything green is a keyword or whatever we want to come up with. We could really build much more understandable, knowledgeable context if we could do this everywhere, especially in our programming environments, in our scripting languages. And our characters need to be accurate and consistent. Right now they're not. You go in and actually try and utilize these character sets, it's impossible. You cannot get them to be exactly perfect. And we should have 1, 2, and 3 dimensional characters. Right now we have 1 dimensional, which is basically our typewriter, 1868 typewriter, that we space over and we put the next one along the x-axis, and so that's why we can't have mathematics. Not without going through a lot of trouble using maybe one font that we kludge up to get our results. And they should all be functional. It means that if you want to rotate them about the center, and they should all be displayable everywhere by any application. And then we get to our values. What values do we need in our computer technology? So we need integers to be fixed as we have now, but we'd like to change the number of bits. We just decided, we're going to let somebody decide that, we're only going to use 8 and 16-bit characters, or it's killing us. Or we could go to a variable number of bits. This number only needs 1 bit. This one we need a Boolean. Right now we use a number. Every application has a different assumption what a Boolean is. I think Oracle uses 1 for true, and I think Oracle uses 0. See, we're dealing with every application has to come up and say, what's a Boolean? Well, what's true and what's false. And we need date is date and time is time. This just kills me. Having a duration from some date in milliseconds or microseconds, and we need bit and bits. So we need 1 bit and multiple bits, so variable length. And we need to be able to do singular and plural of things. And we need understanding on everything, meaning that every bit and byte should have understanding and associated with it, so that when we move it, copy it, display it, whatever, that information is available. And we need as a technology, we want to be able to perform all possible or at least realistic actions on a data structure. So an integer, what can I do with it? I could shift it, I could treat it as 2 bits, I could assume an offset, and there again, this is associated information. And we need control characters, means that we need to be able to divide our information and put control characters in there. We have 1 right now, character term. 2. We have a tab, and I guess if you want to use a space as a control characters, would like to go to term-based and not character-based technology, which is, here's tree. We number those, our characters, we number our characters to the font. If we went to a term-based, then we could reduce the size extremely small. Search would be extremely fast because, is Apple in this file? All I have to do is look in the index and say, yes, Apple's in here. No, it's not in here. Is it case sensitive? Is it underlined? And we could do all kinds of really nice technologies. And there again, we put in style, so we can use underline for particular knowledge. And so in our application development, we really need one action request language. We have billions of languages now, trillions. We got our computer languages, Fortran, Cobalt, and assemblers, and R and Go and Python and JavaScript and Java and billions of these computer languages. And then we have our scripting languages, our BAT files and our JCL and our DEC control languages and just about everything out there. We have stored procedures, we have triggers, we have Excel has its own little language. Every application out there has some sort of language, and that we need to put all in one action request language. Means that we can put in Cobalt and Fortran and whatever else we can install, or we can build our programs from one scripting file. So we can create a hello world and actually put all the, and that gets to our client server logic. We want no client server logic. Literally, we cannot, client server technology does not work. You cannot have two applications work together. It's impossible. We really need to get rid of client server logic. And why do I say this? Bob, let's say your name's Bob. I say, Bob, go to the store and get some bread. You go to the store, they don't have bread. What do? So I'm saying, I'm the client. You're going to go to the store at the server, and you're going to go get bread and bring it back. They don't have bread, or they don't have the bread that I requested, or the road's blocked, or you can't get to it. There's a billion reasons but that's not the store's responsibility. And that's what we're doing now. We're putting the responsibility of, store, if you don't have bread, then throw an interrupter, do something, or maybe, and that's what we're doing. It actually should be up to Bob what to do to determine, okay, in this case, because I know Cliff, the client, and I know what he's going to do. The client knows what he's doing. The store has no idea what you're doing. And so we really need to say, Bob should be able to get on the phone and call me up and say, well, can I switch the bread? Will hamburger buns do? Or, what are my options? And so it's really up to me to determine, well, Bob, just come on back. Or get the hamburger buns, or go to another store, or a billion other things. And then I can change my logic based upon those results. I had a company that was doing money transfers, and they want to do it to all banks, okay, which is great. I want to transfer money, and they could do the transfers. The problem was each of these systems may or may not return that the transaction actually went through. I can transfer it, but do I actually know that it's gone through? I can only do that with some sort of validation. They weren't doing it. The person had to go in literally and check. And so it was up to the individual to go check. Anyway, so you see, you can't. And then how do you validate it? Anyway, and then you don't want billions of these applications of just transferring money. So the client server doesn't work, and I don't care what you do, you cannot get that. The server says, I'm just general, I'll just create some stupid language and you live with it, whatever it is. And when in actuality, we need to be able to communicate back to the client, literally, or have the client actually put in the logic that he needs so that we're not wasting all our time in documentation. And we need it to be hardware independent. So our application record of computer understanding, how do we get that knowledge that we need to process to be hardware independent? We can do this. And then our application development should be professional. Means that right now none of our applications are finished. And so they're really not professional. We treat them as applications. And so we really need our logic and our definition to be user defined. So we don't need developers anymore. We need to build the software and the hardware logic so that we don't need developers. So our expectations of our computer systems. For one, it should be, or we expect it to be, absolutely secure. And we'd like finished products. So whatever product, so when we create this technology, should not have versions. We should not be building applications. We should be building technology so that you want to add two numbers, you add two numbers. You want to divide, you want to do matrix multiplications, you want to do linear algebra, you want to do physics, you want to do dance, music, whatever technology you want. We should be able to get to where they're finished and professionally done. Ownership. What we want is ownership of our own hardware. We don't have it. We want ownership of the information we create. We don't have it. We have proprietary data structures, Oracle and Excel and Word and all these products, billions of products. They each have their own ownership of that application, has ownership of your information. I spent 25 years moving people off of proprietary systems, mapping systems specifically. No company out there is going to publish or give you look at our font technology or our executable technology. The fundamental things that we're trying to program with are not open. They are not. And you say, oh, we got open systems. We got open trivial systems, but nothing of significance. And we expect a technology. We should not have applications. And we should be looking at one application, basically one. Right now we have billions. They're all different. They don't communicate. They don't work together. But we'd like to have just one. Look, I'm doing a map now. I'm doing Excel. I'm doing a spreadsheet kind of thing. Or it should all be handled. And we'd like access to all our source code. Means that if I don't know what's going on, I want ownership, irrelevant of what it's doing. And if it's my banking system or my hospital, I'd like to know exactly what my equipment's doing. And I don't want to be reliant. I want to buy the equipment. I don't want to rent it. I don't want, I want my car. I want it to last 200 years if that's what I want. But not this, we sold you a computer and we don't make it anymore, or we don't support that software anymore. Oh, you just have to buy a new one, which is where we're at today. And sharing. We would like to share all the information that we create. And I'm not talking about sharing with other people. I'm talking about sharing with yourself and within your own company. Here, Bob, open this map and make some edits and send it back to me. Oh, I don't have AutoCAD, or I don't have this mapping system, or I don't have SDO or SDE or I don't have Esri, we'll send you a copy. That's going to cost $45,000, but that's okay. But all I want to do is do a few changes and send it back to you or look at it. We need sharing. And we really, in your own applications, you're sharing information. You're sharing information across functions. And our logic should be professional. We don't have time to finish anything professionally. We don't have partition logic, which is really what we need. So just about everything we have is partitioned in one way or another. And as we get more and more information, we should be able to create professional logic and finish the logic that's actually required and apply it when it's necessary. And understanding. So it's really a complete understanding. Do I understand what just happened to my document? How was it printed? Why did it do that? We need complete understanding. And we only get that with knowledgeable information. And really what we want is progress instantaneously in all technologies, all other technologies. Computers are holding us up. If we can't do mathematics, then math is gone. We can't really do music or dance or physics or chemistry or, these are all specialized programs, applications that are not finished or are unsupported or are supported for a year. We need things that we need to look for the future where things are finished and in 1,000 or 10,000 years, it's still valid. So my conclusion, we need to redesign the hardware into a technology so that it's hard, so that we don't need to be hardware. We should not be reading documentation. The hardware itself should just tell us, okay, I'm a mouse, or I'm a printer, or I'm a whatever. Well, tell me all of the structures and the commands that you would take and the format of those, and just give them to me in computer understandable form. Well, if you tell me to draw a line, this is the coordinate system, and this is how it's all done, and this is how you change paper, and this, and tell the computer, don't tell me. Tell the application, look, application, if you want to know anything, just ask me. If I don't understand anything, I'll tell you that I don't understand it, and let it work itself out. You want artificial intelligence. Intelligence is not what we're looking for. We're looking for understanding, which is, does this program understand how to draw a line on that particular device, or read the mouse movements or the double clicks or anything else? We need that. We need that at the computer knowledgeable stage, and then put that in human understandable stage. And now redesign our software technology, which is, again, getting things out of documentation into computer understandable form, and give us the ability to put our own context in everything. And again, progress for all technologies. We really need not to wait until somebody builds a better font technology. Jesus, I've waited 50 years for a decent font. It doesn't exist. So I'm getting ready to do my own. And no waiting on anyone. So no programmers. The end user should be able to decide what he wants. Right now we're waiting on better compilers, better editors, better printers, better print queues, better. Anyway, that's it for my talk on technology. I think we can move forward. We just have to do it smarter. Thank you for your time. Have a great one. Bye now.